Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Heisenberg and the Quantum Revolution: How Uncertainty Changed the World. In 1901, in the quiet town of Würzburg, Germany, a seemingly ordinary event took place: the birth of a child. On this day, the world did not change, and the course of history was not altered. After all, thousands of babies were born across the globe that same morning, each one no different from the other. Yet, for young Werner Heisenberg, this day marked the beginning of a personal journey that would eventually set him apart from the ordinary, leading him to become one of the most influential figures in the scientific community. Heisenberg was born into a family steeped in intellectual pursuits. His father, a scholar of ancient Greek and Latin, was immersed in the world of classical languages, while his mother, a lover of literature and drama, fostered a deep appreciation for the arts. In their home, bookshelves held more importance than the dinner table, and the sound of a piano often filled the air, more so than the crackling of the radio. Heisenberg's childhood was therefore shaped not by rote learning of mathematical formulas or chemical elements, but by a far deeper, more philosophical education. From an early age, Heisenberg was not the type of child who sought out large groups or loud play. Instead, he preferred solitude, often sitting by the window and observing the movement of tree leaves or the way light and shadow danced on the floor. These moments of quiet contemplation, the seemingly insignificant observations of nature, were the fertile ground where Heisenberg's future scientific curiosity was sown. In those moments, he likely began to wonder what deeper truths could be hidden beneath the surface of these everyday phenomena. It was in this peaceful solitude that the seed of a philosopher was planted. This reflective nature was not only a reflection of his personal inclinations but would later fuel his revolutionary contributions to quantum mechanics. For Heisenberg, science was never just a matter of formulas and experiments. It was a profound journey to uncover the deeper meaning behind nature itself. Perhaps it was this early period of introspection, this quiet time spent observing the world around him, that provided the foundation for his later work. It was from these simple moments of stillness and curiosity that he would eventually leap into the realm of quantum physics. If things had continued as they were, I probably wouldn't be writing this script today, because Heisenberg's childhood wasn't all quiet, poetic moments. The outbreak of World War I hit his development hard. Just like in any other ordinary household, Heisenberg's family wasn't spared from the turbulence of the war. When he was still a child, the war shattered their sense of everyday normality. The streets filled with soldiers' uniforms made the air feel thick with tension, and the growing, bold headlines on newspapers carried an ominous sense of impending doom. Heisenberg's world seemed to flip upside down overnight. The war's end didn't just shift the political landscape of Europe, it plunged Germany into economic collapse and social unrest. In the chaos, Heisenberg realized for the first time that the appearance of order is never guaranteed, and that social stability is often a fragile, fleeting thing. During this stormy time, he inadvertently learned an important lesson: the truly reliable things are often hidden deeper than those outward signs of stability. When the war finally ended, the German currency had nearly lost all value. Trust in society was shattered, and Heisenberg's parents could feel the anxiety from the social turmoil. The family's finances were hit hard. The devaluation of paper money was beyond belief. These chaotic scenes left a strong impression on Heisenberg and made him start reflecting: in a world this unpredictable, is there anything we can rely on? Watching his family and neighbors scrambling to make ends meet, he came to realize that the order of society is not a given. It can be destroyed at any moment. Faced with this uncertain future, Heisenberg began to turn his focus inward, seeking a solid anchor within himself. As the war ended, Heisenberg's thoughts matured. He wasn't a young man panicking over the social upheaval around him. Instead, he was a calm observer, beginning to ask, how does this world really work? He didn't follow the social trends, nor did he get caught up in the political whirlpool like many others. Instead, he started to lean towards science as a way to find a solid ground that wouldn't collapse. Like his father, who studied ancient Greek philosophy. Heisenberg began to look at the mysteries of nature through a more philosophical lens. He wanted to uncover deeper laws, the kind of truths that are not easily shaken. It was around this time that Heisenberg developed a deep interest in physics. He didn't choose engineering, medicine, or any of the more practical fields. Instead, he chose the most challenging and profound natural science physics. He knew that physics wasn't just about solving everyday problems. It was about uncovering the fundamental laws of nature and revealing the workings of the universe. This way of thinking set him apart from many of his peers. He didn't just aim for technical breakthroughs, he was more concerned with the deeper meanings behind the world's workings. His choice wasn't driven by a love of physics, but by his belief that physics would offer him the most fundamental understanding of the world. For him, physics wasn't just a subject, it was a path to explore the very meaning of the world. This also laid the groundwork for his later groundbreaking contributions to quantum mechanics, enabling him to maintain clear-headed thinking and strive for deeper understanding in the most challenging scientific problems. In 1919, Heisenberg stepped into the gates of university and entered the prestigious University of Munich. At that time, Germany had just emerged from the shadows of World War I, and the social and political atmosphere was still heavy. Many people on the streets were weighed down by the devastation of the war and the economic collapse. However, as soon as Heisenberg entered university, he immediately felt a different kind of energy. The academic world was filled with uncertainty, and this uncertainty would become the source of his future thinking. Heisenberg didn't dive straight into mainstream science right away. Instead, he focused on mathematics and physics. His performance at the University of Munich was exceptional, and soon he was taken to one of the world's most important physics research centers, Göttingen. At that time, Göttingen was a place brimming with discussions, debates, and challenges. It was where many of the world's top physicists gathered, and it became one of the most important turning points in Heisenberg's life. In Göttingen, Heisenberg encountered many influential physicists, such as Niels Bohr and Wolfgang Pauli. Their attitudes toward physics and their methods of tackling scientific problems deeply influenced the young Heisenberg. Bohr, for example, was like a machine for generating questions, always raising seemingly unanswerable problems. This approach had a profound effect on Heisenberg. Bohr's patience and method of thinking, especially his reluctance to immediately solve problems but instead repeatedly reflect and discuss them, made Heisenberg realize that the road of science isn't just about stacking up formulas, it's a process full of doubts and explorations. Copenhagen was another crucial testing ground in Heisenberg's life. The Copenhagen School, led by Bohr, proposed a completely new way of thinking to embrace the uncertainty and probability in physics. It was not just a cradle of theoretical physics, but also a research environment rich in philosophical insights. Here, Heisenberg was introduced to the core ideas of modern quantum mechanics, and it was here that he gradually found his research direction. But it was in these dynamic and challenging academic environments that Heisenberg's thinking was fully honed. He shifted from relying solely on experiments and observations to cultivating theoretical thinking, realizing that the essence of physics isn't just about accumulating phenomena, it's about understanding the deep, underlying laws of nature. Heisenberg's academic journey was not without its struggles. While he excelled in the classroom and quickly won the favor of his mentors, he also faced many challenges to his thinking, particularly in the chaotic world of quantum physics at the time. Many theories contradicted each other, and some couldn't even be validated by experiments. Faced with this situation, the young Heisenberg began to deeply reflect: where should physics truly begin? In his early research, Heisenberg tried to rely on experimental data to validate his theories, but he soon realized that relying solely on experiments wasn't enough to solve some of the core problems in quantum mechanics. Quantum mechanics isn't like classical physics, where conclusions can be drawn from intuitive experiments and observations. Instead, it's more about the mathematical abstraction of natural laws. This realization led Heisenberg to understand that physics isn't just about piling up experiments and formulas, it's about how you view the world. This insight made him realize that the limitations of experiments mean that scientific exploration cannot stay on the surface. It must dive deeper into theoretical construction. This shift marked a key turning point in Heisenberg's academic career. He started stepping away from experiments and turned toward more abstract theoretical exploration, starting to propose innovative ideas. It was during this time that he realized quantum physics wasn't a deterministic, predictable field like classical physics. Instead, it was all about probability and uncertainty. And this uncertainty wasn't just unknown, it was an inherent feature of the quantum world. Heisenberg's shift meant a fundamental change in the approach and philosophy of physics research. He began to believe that the true meaning of science was to uncover the laws and principles of nature. And these laws weren't fully deterministic. They came with built-in uncertainty. This philosophy laid the foundation for his later work on the uncertainty principle and also set the stage for his monumental scientific achievements. In 1925, the United Kingdom was grappling with two major political and social issues: the return to the gold standard and the rise of the Labour Party. To stabilize the economy, the British government decided to return to the gold standard. But the decision didn't bring the expected economic recovery. Instead, it exacerbated inflation and unemployment. At the same time, the Labour Party began to emerge as a significant force, laying the groundwork for future political reforms. Calls for social reform were growing louder, and the UK was taking a big step towards modernization. That year, Heisenberg introduced matrix mechanics, a groundbreaking new way to describe quantum mechanics that completely shattered the traditional views of physics at the time. Matrix mechanics wasn't just a mathematical tool, it was a profound understanding of the quantum world. The theory described the behavior of particles like electrons in the microscopic world in a way that was entirely different from classical physics. Like many pioneering theories that are right but ahead of their time, Heisenberg's breakthrough wasn't immediately accepted by everyone. As I type these words, I wonder if all famous, great theories were once met with skepticism or rejection. Indeed, many scholars vigorously opposed Heisenberg's theory, especially traditional physicists, who felt that Heisenberg's quantum theory was too abstract and lacked intuitive experimental validation. However, Heisenberg didn't back down. Instead, he delved deeper into exploring the true nature of quantum mechanics. He didn't see quantum mechanics as just a simple mathematical tool, but as a revelation of the underlying laws of nature. He believed that physics shouldn't stop at the visible phenomena but should seek out the hidden, potential laws that govern the universe. This also led Heisenberg to rethink the measurement problem in quantum mechanics. He started to realize that the unknowability of the quantum world didn't just stem from limitations in experimental technology but was a fundamental property of nature itself. This unknowability came from the heart of quantum mechanics: the dual nature of particles and waves, and the universality of uncertainty. The depth of quantum mechanics not only changed the way people understood the material world but also prompted Heisenberg to reflect on the relationship between science and philosophy. For Heisenberg, quantum mechanics wasn't just a branch of physics, it was a profound reflection on how humanity understands the world. His shift from experiment to theory gradually shaped his unique philosophy of science. Science is not just about discovering what is, but understanding why and how. After years of academic development, Heisenberg transformed from a young student into one of the leading scientists of his time. He didn't just stand out because of his personal brilliance, but because of his deep insight into the essence of quantum mechanics. His growth story mirrors the development of modern physics, starting with exploration and doubt, followed by theoretical breakthroughs, and ultimately leading to philosophical reflections on science. Heisenberg's journey shows how scientists find direction in the midst of confusion and advance to the cutting edge of scientific revolution in times of turbulence. Heisenberg discarded the image-based thinking of classical physics and introduced a brand new theoretical framework: matrix mechanics. The essence of this theory wasn't to pursue precise images or clear-cut orbits, but to describe the state of a quantum system using mathematical matrices. Matrix mechanics didn't rely on traditional concepts of space and position but instead used matrices of quantum states to describe the system's energy and other measurable quantities. At first glance, this idea seems highly abstract, but it accurately revealed the uncertainty in the quantum world. Heisenberg realized that in the quantum world, quantities like a particle's position and momentum cannot be simultaneously measured with precision. This uncertainty wasn't a technical issue, it was a fundamental property of nature. This breakthrough wasn't just the introduction of a mathematical formula, more importantly, it brought a deep understanding of the world. Nature's truth was not as precise and predictable as Newtonian physics, rather, it was filled with randomness and uncertainty. The matrix mechanics Heisenberg introduced at that time, though not initially accepted by the public, laid the groundwork for the mainstream framework of quantum mechanics. The essence of matrix mechanics was a complete overthrow of classical physics, marking the arrival of the quantum revolution. This theoretical breakthrough no longer relied on intuition or images, but used more abstract mathematical tools, paving the way for the further development of quantum mechanics. After completing his paper, Heisenberg sent it for peer review. Despite its revolutionary nature, the response wasn't as enthusiastic as he had hoped. In fact, it was full of skepticism. Older physicists, especially those leaning towards classical physics, couldn't accept Heisenberg's abstract mathematical approach to quantum mechanics. They felt Heisenberg had overlooked experimental validation and ignored the intuitive nature that physics should have. None of this surprised Heisenberg. He had long been prepared for criticism, standing at the forefront of science. Heisenberg wasn't motivated by personal glory. His concern was never about academic disputes but about which theory could best face the unknown. For him, the value of a theory wasn't in how much fame it brought, but in how much it revealed the essence of the world. Heisenberg calmly faced the opposition from the traditional physics community. He wasn't in a rush to provide answers but preferred to remain open-minded during discussions. In this scientific battle, Heisenberg's composure and focus were unmatched. Although matrix mechanics faced considerable opposition, Heisenberg firmly believed that physicists should step outside traditional frameworks and embrace an open mindset to understand the quantum world. Soon, Heisenberg's theory gained recognition from other physicists, especially Niels Bohr, who had a close relationship with Heisenberg. Bohr highly praised Heisenberg's matrix mechanics and engaged in in-depth discussions with him. Bohr's support helped matrix mechanics gain widespread attention in the academic world. The gradual acceptance of this theory was a crucial step in transforming quantum mechanics from a niche theory to the mainstream of modern physics. However, Heisenberg knew that the acceptance within the physics community didn't mean ultimate victory. He knew that the ultimate goal of science wasn't just to get a theory accepted, but to validate that theory's correctness through experiments and observations. For him, the true challenge of physics was to make these abstract mathematical formulas stand up in the real world. The introduction of matrix mechanics not only changed the way physics was described but also propelled Heisenberg into one of the great scientific revolutions in history. Over time, Heisenberg's theory became a core part of quantum mechanics, which itself marked the fundamental shift from classical physics to modern physics. At the same time Heisenberg was developing matrix mechanics, Schrödinger was conducting similar explorations and eventually proposed wave mechanics, a theory that leaned more towards describing quantum systems with wave functions. The differences in discussions between the two helped facilitate a significant revolutionary fusion in quantum mechanics. The argument between Heisenberg and Schrödinger wasn't just about the superiority of a mathematical tool, it reflected different understandings of the quantum world and different philosophical stances. Heisenberg's matrix mechanics, with its precise mathematical framework, captured the core features of quantum mechanics: uncertainty and randomness. Schrödinger's wave mechanics, on the other hand, emphasized describing particle behavior through wave functions and proposed the wave-particle duality of quantum mechanics. Although this debate caused confusion in the physics community at the time, from a historical perspective, it provided the crucial step towards the formal establishment of quantum mechanics. As one of the leaders of the quantum revolution, Heisenberg's contribution was not just in the development of matrix mechanics but in his redefinition of how scientists should approach uncertainty. Unlike many physicists, Heisenberg didn't try to control nature but worked to understand and accept the complexity and randomness of nature. For him, science wasn't about domination but about exploring the unknown and accepting uncertainty. Heisenberg's matrix mechanics wasn't just a theoretical breakthrough, it deeply influenced the direction of physics research that followed. Over time, quantum mechanics became the cornerstone of modern physics, a crucial tool for explaining the microscopic world. From the birth of quantum mechanics to today, Heisenberg's name has been inseparable from the field. After the quantum revolution, many assumptions of classical physics began to be questioned. For example, the classical idea that objects exist in a definite way was completely overturned by quantum mechanics. The core principle of quantum mechanics tells us that microscopic particles don't have a fixed position or path, but instead exist probabilistically. And that's exactly what Heisenberg's uncertainty principle is all about. This discovery didn't just affect physics, it had a profound impact on philosophy, computer science, and even the development of future technologies. The impact of the quantum revolution spanned the entire 20th century. It wasn't just a victory for physics, it was a radical shift in how humanity understands the world. Today, quantum mechanics is an indispensable part of modern technology, from quantum computers to nuclear energy, from medical imaging to semiconductor tech, all inspired and supported by quantum mechanics. Heisenberg's contributions went far beyond that of a typical scientist. He didn't just make decisive contributions to quantum mechanics, he deeply explored and interpreted the relationship between scientific thinking and philosophy. His story remains a legendary chapter in the history of modern physics, and its influence is still felt today. In 1927, Heisenberg proposed the uncertainty principle, which changed the way we understand the world. At first glance, the name might make you think of a fuzzy, uncertain worldview. But the reality is much more complex. It doesn't mean we lack knowledge, but rather that we can't fully know everything. Heisenberg's theory revealed how the observer affects the observed phenomena in the physical world, and pointed out that the universe isn't a mechanical clock that can be strictly predicted, it's filled with randomness and uncertainty. So, what exactly is the uncertainty principle? In simple terms, it tells us you can't know a particle's position and momentum at the same time. Precisely. And it's not just a limitation of technology or measurement tools, it's a fundamental law of nature. You may have heard of the unknowability of the quantum world, but Heisenberg's principle turned this unknowability into a physical law, telling us this isn't just a random limitation, it's a fundamental property of the universe. I could go deeper here, but this is Heisenberg's story, not just the uncertainty principle. Or to put it plainly, I'm still not sure I fully get it myself. When this theory first came out, it left almost all physicists dumbfounded. Human society had gotten used to thinking of the universe as governed by clear laws, predictable, gravity, Newton's laws. They gave us a clear view of the world. But Heisenberg's principle ripped that picture apart. Nature isn't fully deterministic, it's dynamic, filled with randomness, even a kind of chance. For many people, this conclusion was unsettling. After all, uncertainty means we can't control everything. Imagine if you couldn't accurately predict tomorrow's weather, or if you couldn't determine a particle's path. What does that mean for a civilization built on the idea of control? It's a nightmare. But for Heisenberg, this was the true understanding of the world. Uncertainty isn't chaos, it's an intrinsic limitation of nature. He believed that humanity's constant pursuit of perfection and precision might, in some areas, never be fully achieved. What scientists can do isn't eliminate uncertainty, it's to find patterns in an uncertain world and accept the fact that you can't control everything. This understanding made Heisenberg's work even deeper and more meaningful. It wasn't just about experimental data anymore, it was about understanding nature through philosophical thought, reaching new heights. Heisenberg wasn't just a physicist in a lab, he was also a man who embraced social responsibility. During World War II, with the rise of the Nazi regime, a huge shadow loomed over Heisenberg's scientific path. He got involved in Germany's uranium project, the attempt to develop the atomic bomb. This decision pushed him to the crossroads of ethics and politics, forcing him to face a huge moral dilemma. Imagine this: when Heisenberg stood at this historical crossroads, he wasn't just wrestling with the question of, should I join the development of nuclear weapons? He knew that every step he took in science could stir up political waves. Physics and politics are never completely separate, they're always intertwined. While Heisenberg wasn't a supporter of the Nazis, he knew every action of his could be used by the Nazi regime. As a scientist, Heisenberg knew that at one of the darkest moments in human history, his work could be turned into a weapon of war. He didn't want to create destructive weapons. He understood the devastating power of the atomic bomb, but in wartime Germany, he couldn't escape the pressure from the state. Through this process, Heisenberg's heart was full of confusion and unease. Could he really refuse the project? If he did, would someone else take over the research? Possibly someone with a different attitude toward the war? More importantly, if he joined in, would it mean he was helping lead humanity to self-destruction? This wasn't just a technical choice for a scientist, it was a political and ethical decision. History doesn't easily provide an answer, and Heisenberg's choice remains a focal point of discussion in academia and among the public. Some argue that Heisenberg's involvement ultimately led to the failure of the Nazi atomic bomb project, which could be seen as a moral victory for him, but others believe his participation was tacit approval of the war, even enabling it. This moral dilemma made Heisenberg's personal growth more complex. As a scientist, his desire for truth about the natural world was endless, but as a human, he also understood deeply that science and social responsibility are closely connected. He wasn't just dealing with how to discover natural laws, he was wrestling with how scientific knowledge should serve the welfare of humanity. After the war, Heisenberg had to face not only Germany's defeat politically and socially, but also the moral judgment of his own actions. Under the surveillance of the Allied forces, Germany's top scientists were gathered for reflection and investigation. The conversations of Heisenberg and other physicists were recorded in detail. Later, historians found that Heisenberg was particularly silent when facing his own role. Unlike some scientists, he didn't vigorously defend his innocence. Instead, he chose more self-reflection and deep inner thought. For Heisenberg, science wasn't a magic tool. It couldn't just focus on accumulating knowledge without considering the moral and social responsibility behind it. This reflection didn't just deepen his thoughts on quantum mechanics, it also made him reconsider the role of scientists after the war. Science should move forward, but it must always maintain reflection on society and ethics. His post-war reflection on science ethics prompted Heisenberg to walk more cautiously at the intersection of science and society. He began actively participating in international scientific conferences, publicly calling for scientists to pay more attention to their social responsibility while pursuing technological progress. This transformation showed how Heisenberg shifted from being a pure physicist to a more holistic scholar with social responsibility. The shadow of World War II gradually faded, but Germany was left in ruins. After the war, it wasn't just the cities that needed rebuilding. The scientific community took a huge hit too. Labs were destroyed, many scientists scattered, and the research environment was nearly paralyzed. For Heisenberg, seeing his homeland and scientific work in decline was a massive shock, but instead of running away or giving up, he dove into rebuilding German science. Heisenberg knew that while war destroyed the country's infrastructure, what truly needed rebuilding was society's trust and moral fabric. He wasn't just focused on reviving physics, he cared about the connection between science and society, and the responsibility that came with it. He realized that science wasn't just about understanding the mysteries of nature, it was about transforming the deep knowledge into the welfare of humanity. Scientists shouldn't live in ivory towers, they should shoulder the responsibility of helping society move forward. In this process, Heisenberg's role gradually shifted. He was no longer just a theoretical physicist, he became a bridge between science and ethics, theory and practice. This transformation wasn't just a change of mind, it was a profound understanding that scientific progress must be tightly connected to social responsibility. While his passion for quantum physics still ran deep, he now thought more about how to use knowledge and technology to make society better. For instance, Heisenberg began paying more attention to the public impact of science. He understood that while science drives technological innovation, it often overlooks the social consequences of that technology. Because he had personally experienced the destructive impact of the atomic bomb during World War II, he became even more convinced that scientists must take on greater moral responsibility. So, he began to frequently address the ethical issues that technological progress might bring in his public speeches, urging scientists to stay vigilant for the welfare of humanity while creating new technologies. After the war, Heisenberg didn't just continue his research in quantum physics, he also contributed to rebuilding education and academic organizations. He worked to secure resources for young scholars, advocated for ethical reflection in science, and emphasized the importance of academic freedom and research ethics. All this shows that Heisenberg didn't just make groundbreaking contributions to physics, he played a key role in the moral reconstruction of post-war society. As Heisenberg grew older, his focus shifted. No longer just chasing equations and theories, he started asking bigger, more existential questions. He began to think about knowledge itself, its limits, its potential, and the role science plays in shaping society. And for someone who had already revolutionized physics, the question was no longer just about solving problems, but about how humanity, having unlocked so much knowledge, could avoid losing its way. Heisenberg wasn't just a scientist, he was a thinker who understood that wisdom isn't about what we can do, but how we choose to use our abilities. Technology, he said, isn't just for making life easier or more productive, it's a tool for progress, for creating a better world, or, if mishandled, a force for destruction. He reminded everyone, time and again, that science's true value lies in its ability to help us make decisions that are not just smart, but ethical and socially responsible. And this thought process connects back to his uncertainty principle, the idea that the world is not as predictable as we'd like it to be, and neither is science. As Heisenberg entered his later years, he became obsessed with the broader philosophical implications of quantum mechanics. It wasn't just a new theory about particles, it was a new way of thinking about the world. In the quantum universe, the goal wasn't precision and perfection. Instead, we're learning to accept the inherent fuzziness of nature. This radical shift made Heisenberg even more convinced that the future of science isn't just about pushing forward technology, it's about asking deep, uncomfortable questions about existence, morality, and what it means to be human. In his later lectures, Heisenberg often pointed out that technology is a double-edged sword. It can drive humanity toward incredible advancements, or it can tear everything down in the blink of an eye. Scientists, he said, are not just creators of knowledge, they are stewards of society. The responsibility of science, in his eyes, wasn't just to uncover how the universe works, but to make sure those discoveries are used to build a more moral, responsible world. For Heisenberg, quantum mechanics wasn't just about formulas, it was about redefining how we relate to nature itself. It wasn't about controlling the world, it was about understanding that we never will. In that realization, Heisenberg found a kind of wisdom that went beyond what any scientist could achieve in the lab. The real challenge, he believed, was accepting the limits of knowledge and learning to live with uncertainty and humility. Heisenberg was one of the first to recognize that scientists have to be aware of the consequences of their work. Science itself doesn't carry a moral compass. It can be used to benefit humanity, or it can be turned into a tool of destruction. This awareness became a central theme in Heisenberg's later life. He began to ask himself and later others how scientists could prevent the misuse of their discoveries. In the realm of quantum mechanics, where technology could bring about breakthroughs, he understood that the application of science had to be examined through a strict ethical lens. Only then could it serve humanity in a truly positive way. Heisenberg didn't just talk the talk, he acted on these thoughts. In his later years, he became a strong advocate for science education that didn't just focus on technical skills but also on the social responsibility that comes with those skills. Scientists, he argued, couldn't afford to ignore the potential consequences of their discoveries. They had to take responsibility for the future. And in his view, this philosophy didn't just shape his own life, it would go on to influence a generation of scientists who would approach their work with a stronger moral compass. But Heisenberg's reflections weren't only about ethics. From the very core of quantum mechanics, he saw science as a bridge between philosophy and reality. Quantum mechanics wasn't just a tool in the physicist's toolkit, it was a fundamental challenge to how we see the world. It wasn't about control, it was about accepting the unpredictable, the uncertain. For Heisenberg, this wasn't just a scientific realization, it was a deep, philosophical shift. Through quantum mechanics, Heisenberg saw that human perception is inherently limited. Science gives us powerful tools, but it doesn't offer complete truths. What it provides is a way to navigate the world with partial, yet valuable insights. This realization didn't just make Heisenberg humble, it made him passionate about the need for humility in all scientific exploration. Heisenberg's journey wasn't just about understanding nature, it was about understanding how science should fit into society. And in his eyes, true wisdom wasn't about controlling the world, it was about knowing we can't control everything and making the best choices we can within our limits. This wasn't just a guiding philosophy for Heisenberg, it became a lesson for generations of scientists who followed in his footsteps. As Heisenberg grew older, he didn't just become a scientist, he became a philosopher of science. His contributions to physics were undeniable, but it was his life's journey that showed the world how science and philosophy could meet. He left behind a legacy that goes beyond equations and theories. It's a reminder that science isn't just about discovering facts, it's about understanding the deeper truths about who we are and what we stand for. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.